Hey everyone, today we are going to be going over 3D equilibrium given a max tension. So let's look at this problem real quick. If we have 3 ropes, it might be a little hard to see, I know I'm not the best at drawing, but if we have 3 ropes, 1, 2, 3, with a weight attached to those, and we know that the max tension in any rope can be 1,000 pounds. What is the max weight that you can have? Okay, so basically if you look at it from a design standpoint, you're saying, well, we have these ropes. I know that each of them can hold 1,000 pounds before they break, and I'm going to set them up in this orientation and hang a weight from them. What is the maximum weight that I can hang from these ropes before they break? Well, that's what we're going to find out here. If you notice, we don't know F1, we don't know any of the tensions. Let me change these tensions in the rope. T1, T2, T3, but given this, we still can find the max weight that we can hold. All right, so now that we know what we need and what we have, let's think about this for a second. To be able to get this, well, we need to do the sum of the forces in the x equals 0. Sum of the forces y equals 0, and sum of the forces in the z equals 0. Okay, there are 3 equations we have, but if you notice, we have 1 unknown, 2 unknowns, 3 unknowns, 4 unknowns. So we need one more equation to be able to solve this. Well, the last equation, we know that the max tension in one of these has to be 1,000 pounds. So we'll just set one of them equal to 1,000. For simplicity, we're going to say T1 equals 1,000. So there are our 4 equations, excuse me. Okay, and now to be able to do some of the forces in the x, y, and z, we have to break up these tensions into their x, y, and z components. We're going to be doing this symbolically. It's no big deal. What I always tell all the students that come in and see me is don't be afraid to work in unknowns. And that is the biggest key. You can have 10 different equations with 10 unknowns and not know any of them and still be able to solve it. Anyway, so let's just start doing this. Now we have a bunch of positions, so we know that we're going to be using unit vectors to break these up. So let's get position vectors first. Position vector 1 for T1 equals, well, how far does it go in the x? It goes, or sorry, that's the y. How far does it go in the x? It goes -1 in the x. It goes, how far in the y? It goes -2 in the y. How far in the z? Well, it goes up 2. Okay. And then for the magnitude, we just do the square root of the sum of the squares. So the square root of 1 squared plus 2 squared plus 2 squared. And that is going to give us 3. Okay. Those 2. So now let's move on to our position vector for T2. So R2. How far in the x? Well, it goes -1 in the x, 1.5 in the y, and then 3 up. Okay, so now we get the magnitude of that, and that's going to equal 3.5. off. Okay, so now we'll move on to the third one. T3 is over here. How far in the x? It goes 3. And it goes -4 in the y. And then it goes 0 in the z. And I know a lot of people like to just use final minus initial. Say initial is 0, whatever. You can do that if you want. May work easier for some people, but I just count how far back it goes. Let's get this a little straighter. Okay, so now we need the magnitude for our tension 3, and that is 5. Okay. So now that we have the position vector and the magnitude for each of these ropes, we can find the unit vectors. I need to erase just a bit here. Okay, so unit vector 1 equals -1 over 3, comma, -2 over 3, comma, 2 over 3. Unit vector 2 equals -1 over 3.5, 1.5 over 3.5, and then 3 over 3.5. Okay, and then unit vector 3 equals 3 over 5 and -4 over 5 and 0. Okay, now we have a little bit more room to work. Okay, and if you want to get the force for these, well, we just multiply our force through our unit vector. So -1/3 times T1, -2/3 times T1, 2/3 times T1. So we'll just do that with each of these. Okay, and given how vector multiplication works, it just multiplies them all through. Okay, so now we're going to set up the rest of our equations. Sum of the forces in the x equals 0. So we have -1/3 T1 minus 1 over 3.5 T2, and then plus 3 over 5 T3 equals 0. Okay, now for the sum of the forces in the y equals 0. We have -2/3 T1 plus 1.5 over 3.5 T2 minus 4/5 T3 all equals 0. Okay, now we're going to do the sum of the forces in the z equals 0. Okay, and for this, we don't want to forget our weight that's hanging down. So we have 2/3 T1 plus 3 over 3.5 T2 plus 0. Wow, we're not going to include that in there, minus W equals 0. Okay, now we have our 4 equations. We have T1 equals 1,000 pounds, sum of the forces in the X, sum of the forces in the Y, sum of the forces in the Z. So 4 equations, 4 unknowns. Can just plug this straight into a simultaneous solver. There should be another video on how to do that on a TI calculator. Not sure which version, but if you're having trouble, you can look it up online. You can use matrices, you can use any method you want, really. Anyway, so assuming that T1 equals 1,000 pounds, we plug that into our simultaneous solver, and we get out T1 equals 1,000, T2 equals... Okay, so let's look at these numbers for a second. We have T1 equals 1,000 pounds, which is the assumption that we made. T2 equals 23,333 pounds. T3 equals 11,666, and the weight that we can hold is 20,666 pounds. Now, we should automatically know that this cannot be correct because these tensions are above 1,000 pounds. Those ropes would break in no time at all. So, what does that tell us? We did something wrong. Well, our assumption was wrong. T1 can't be 1,000 pounds. It never reaches 1,000 pounds. So, what do we do next? We change our guess. And you should really only have to do this 2 times if your assumption is wrong the first time. If you come down here and look at the max tension, well, that would be T2, 23,333. This will always be the max tension. So now we're just going to say that T2 equals 1,000 pounds because that one came out to be the largest number. Okay? And rerunning our simultaneous solver with that gives us T1 equals 42.85 pounds. T2 equals 1,000 pounds. T3 equals 500 pounds. And our weight comes out as negative 885. So just 855 pounds. We don't care about the negative sign because we know it's going down. So that is our answer right there, this 885 pounds. If we're given a max tension in these ropes of 1,000 pounds before they break, this is how much we can hold up.